not this m, actually it would be small m, right? So this is what we are left with if I take m common out. Now I want to make this equation in the format that I want capital M here, which is the total mass of the body. So what should I do? How many particles are there? There are a number of particles. So if I multiply n with this equation, I'll get the total mass. So what I'm doing is I'm multiplying and dividing this equation by n. So I'll have m into n, r1 square plus r2 square plus rn square divided by n, right? This thing solves the purpose. So mass, n number of particles, each of mass m is giving me the total mass of the system. So this is half m times this, which is r1 square plus r2 square plus dash 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 rn square whole divided by n. If I equate, because according to the definition of radius of gyration, the moment of inertia about this point P, it is the perpendicular distance from that point P, which what is the point P? Where whole mass of the body is concentrated. The body will have exactly same moment of inertia as it has with the actual distribution of mass, which is this one or this one. And with particle P, this is the moment of inertia. So what we have to do? We have to equate equation 1 and 2. So on equating 1 and 2, what will I get? Half mk square is equal to half m times this one, r1 square plus r2 square plus dash 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 rn square divided upon n. So these things get cancelled out and I am left with k square is equal to this term. That means k is equal to under root of the squares of individual distance of each particle, their addition divided by total number of particles upon n. This is the radius of gyration for a given distribution of particles across a rigid body.